Welcome to ADF Insider. This is the second part of a two-part series about ADF Task Flow. My name is Frank Imphius and I'm from the Oracle JDeveloper team. In the first part of this series we talked about task flow concepts. We talked about the difference between unbounded and bounded task flows and how they relate to the standard Java Server Faces navigation model. We talked about exception handling and we rounded up with train model and how you can use trains in a bounded task flow for navigation. In the second part, we will start off with talking about memory scopes. We will talk about how to expose a bounded task flows in ADF regions, how to snapshot the current state of a task flow and to recover to it to a later point in time. I will show you how you can expose a task flow in a dialog. And finally, how to deploy a task flow to a remote server and then access this deployed task flow from a local application so that you can have this operating like a service. Before we go into part 2, let's have a quick look at the demonstration that we built, the sample application that we use to guide us through the different options and properties that you can work with when you work with ADF Task Flow. What we built in part 1 is an application that consists out of two bounded task flows and one unbounded task flow. We have a master detail relationship between a parent page, which shows department data, and a bounded task flow, which is exposed in an ADF region showing the employee data for the selected department. So one part of the task that we had to do when building the demo was to enable synchronization between the parent page and the child page, which we did by using an input parameter on the bounded task flow for the parent page to pass the department ID into. And then with that information, the employee overview bounded task flow actually executed its own query to filter the return list of employees accordingly to the passed in department ID. And then we had another task flow that could be called from the employee detail task flow for further editing a selected employee. So let's have a look at the task flows that we created. So let's first go to the detail task flow. This detail task flow is created with a page fragment which has a table in it, and it starts off with a default activity that sets the department ID to a bind variable. And the department ID, it reads from the input parameter that we get from the parent page. Then it executes the query, navigates to that page, and then from this page you can use a task flow call activity to start off the employee edit task flow. And here what you see is that navigation takes place using a train model. Of course, this could be also managed with control flow cases, but just to showcase a train model and how to work with that, we decided to have the train model being used for this bounded task flow. At the end of this task flow, you either commit or rollback. Well, it's not really a commit and not really a rollback because it's just a submit, because the bounded task flow we see here is sharing the data control and therefore sharing the transaction. So we're just returning from this bounded task flow, either rolling back to a save point that is implicitly set when you access this bounded task flow, or just submit and return, and so that you continue in the employee detail task flow, changing other data or just browsing for other employees. Let's have a look at the HR page just to see how the train model looks. The train model is using an AF train component to expose the different train stops. At design time you just see one stop. At runtime you will see as many stops as you have train stops defined in the bounded task flow. So let's continue with the slides. In the first lesson of the second part we talk about memory scopes. As you know, there are memory scopes defined by the servlet specification, and developers use those memory scopes in different technologies, JSP, servlets, but also Java Server Faces, to temporarily store objects there. Some objects are required just for a short time, others are required for longer to access by the application. There are additional memory scopes in ADF controller and in ADF faces that you can use during building your application, and I introduce them all in the order of the length. So the maximum length you get for a scope of application. So every attribute, object or managed bean that you put into an application scope will last for as long as there's a user working with an application, and it's shared across users. So it's not identified by a specific user. This scope is for every user. It's like a singleton. So whatever you put into this scope will become available for all users. This really is a rarely used scope, and it's not used by individual user sessions, so mostly that is used for some configuration data that is good to share across users. And the next larger scope is session. Session is smaller than application but still larger than request or the other scopes. A session exists for the duration of a user working within an application. This is the same in JSP or in Servlet. The danger with session is that you store information in the session, you forget about it. So you might need information on the first page of an application or maybe in the second page, and then you forget to delete this, which means that things start hanging around in memory, are not getting cleaned up, which is not a good thing to do. So you have to have a good memory if you use session. Information that should go into the session scope is information about the user, for example. So once the user logged in, you might fetch additional information about the user from some HR database, and that information you want to make available throughout the application, in which case the session might be a good scope to put that in. The first ADF specific scope is page flow scope, and page flow scope is smaller than session but still larger than request. Every task flow, unbounded or bounded task flow, has a page flow scope automatically created. The page flow scope lasts for as long as the task flow is active. The unbounded task flow is active for as long as the application runs, and you would think that that is equivalent to a session. It's true in the sense that it has the same duration like session, but as soon as you start calling out to a bounded task flow, so you're navigating away from the unbounded task flow, then the page flow scope will be suspended and put on a stack where it will be recovered later. So to this point it's no longer available. Instead, what becomes available is a page flow scope of the bounded task flow that you're calling. So you always have a memory scope that is called page flow, but this page flow scope is always dedicated for the task flow that you're in. Once you exit a bounded task flow, then the parent task flow is reinitialized, so not really restarted, but actually it's picked up again, so it's taken from the stack, and then the parent task flow's page flow scope becomes available again with all the objects in it. A parent page flow scope cannot peek into the called bounded task flow page flow scope, and vice versa. So page flow scopes are isolated memory scopes that are available for the duration of the task flow. The next smallest scope is view scope. In traditional web application, we're so much used to that when we send a request to the server, that this goes in line to a refresh of the page. Now this has all changed with Web 2.0 and rich internet. The view scope orientates itself on the view ID of a specific page or page fragment. So let's start with a page. Unbounded task flows have pages. Bounded task flow might use JSPX documents to navigate from one page to the other as well. This is more like the traditional way of navigating. However, within the pages, you might send multiple requests to the server to fetch data, to execute functionality. In reality, you could really stay for 10 minutes, 15 minutes, 20 minutes, or even more on the same single page while still working with the application, sending requests to the server. And whatever you put into the view scope and this memory scope as an object or information will last. So it's not forgotten only because you send a request to the server. Even if you redirect to the page, so for some reason you have to redirect to the same page, because the view ID doesn't change, the view scope is kept. So view scope is something that you can use to store temporary information or even manage beans that you use on a specific page, and that information that you want to keep between requests to the server. And this is view scope, and this is specific scope to ADF and ADF controller. The next standard scope is request. A request has a duration of the client pinging the server and the server answering the request. This is the lifetime of a request scope. So every object in a request scope will be cleared out and deleted and forgotten once the server responded the request, because then a new request scope is available which is emptied. The request in an ADF Faces application could be a partial request, like you're scrolling in a table. Now this sends a lot of requests to the server, and at the end of each of this scroll of this data fetching, there is a response sent from the server which ends the request scope. The request scope is a very small scope, and the information in there at the end is all cleared up. Backing bean scope is the scope that is defined for ADF controller. The backing bean scope actually has the same duration as request. The only difference is that it's bound to a specific instance. As an example, in ADF Faces you can build declarative components. So that is that you use a wizard to build your own component out of existing components in ADF Faces. If such a component uses a managed bean to perform some calculation or to hold some state, some value, then this managed bean, if it's put into request scope, will have a problem with multiple instances of the components being used on a single page. Imagine you have this declarative component and maybe an address field or wherever your custom address field with a pop-up bound to it. So you drag and drop this component onto a page. As soon as you start entering data into your component, if this is saved up in the managed bean that the component used, then if you add a second declarative component, this second instance of the declarative component will feed into the same managed bean, which means it's overriding the information coming from the first use of the declarative component. And this exactly is what backing bean prevents, because the backing bean allows you to have an instance-specific request scope created. So you have information that you save for the duration of the request, but for a specific instance of a declarative component. And then there is another scope which is called none, which is definitely the smallest scope. None is like having a static library. You know that especially Java developers are so much used to have libraries that provide static methods and static information so that they can access this easily in form of a helper method. If you configure a managed bean to be in a scope of none, then this bean will not save any state. So there's no state at all saved. So if you try to put a value into it, this is gone immediately. But you can invoke methods on it. And the difference between a library of static classes and static methods and a managed bean in non-scope is that the managed bean in non-scope is accessible through expression language, which will allow you from the user interface to access functionality in that bean, and of course have a library of those managed beans that are then expression language accessible. In reality, the non-scope is really rarely used, and most developers tend to use request scope, or if you're an ADF developer, backing bean scope. And you will see a lot of default settings and default code that gets created or configuration that gets created by Oracle JDeveloper uses the backing bean scope or the request scope. Before we continue developing our sample application, we first need to introduce the concept of ADF region. So what is a region? An ADF region is a bounded task flow that is exposed on a specific area on a page or page fragment. A region executes a bounded task flow instantly. That means that there's no refresh of the view that contains the region. You can also have many different regions on the same view, in which case you have kind of a desktop appearance or dashboard style of page that you can build, and each of the regions can have its own state in the sense of that it can navigate within the bounded task flow that it represents without impacting any of the others. But it can also create synchronization between the different regions so that they communicate with each other. In our example, we do have the case where the region is refreshed and synchronized with the department selection in the parent page. Now you can also have two regions, two different bounded task flow, one presenting the parent information, the other one the detail information, and then establish synchronization, communication between the two regions. In ADF, clearly the concept of ADF regions is the key enabler of Web2 development, giving us this rich, fresh user interface that we all know from Web 2.0 applications. In ADF we do have two flavors of ADF regions. One is a static region and the other one is called the dynamic region. A static region always points to the same bounded task flow. So this area of your page will never ever see any other bounded task flow than the one that is configured as design time. The dynamic region uses a managed bean to dynamically reference a bounded task flow. So this region can, dependent on some condition in your application, show a completely different bounded task flow in this area on the page. The dynamic region is the basis of the UI shell layout pattern. It's a template that we ship with the latest releases of Oracle JDevelop 11G. This template provides you with some areas, predefined areas, on a page or on a page fragment that then you can use the UI shell infrastructure managed bean to dynamically display or hide bounded task flows. A bounded task flow is exposed through an ADF region, and it doesn't matter where the ADF region is. It could be on a panel tab layout, it could be on an accordion like in this screen here, and then it executes the bounded task flow. I briefly mentioned this in part 1. Usually a bounded task flow that is exposed in an ADF region runs in circles, so there's no exit to this bounded task flow. It can call other bounded task flows that then have an exit to return to this bounded task flow, but itself usually runs in circles, so it processes a task and then starts all over again. You can of course have an exit or a return statement within the bounded task flow that is exposed as a region. In this case, which is a specific use case, really going beyond of what we want to teach in this session, you will have to listen for this exit criteria, and then in Java code you can make sure that the whole region gets refreshed and then properly restarted. But it's an option that you can do. So what are the ingredients of an ADF region? First of all, to start with, is an ADF faces tag. There's an ADF region tag, and at runtime this is represented by an object which is a rich region object. The ADF faces region tag references in its value property a region model, and the region model could be something that in the open source land you program yourself, or in the ADF world what you would expose through the task flow, through the bounded task flow. So there's a task flow binding which exposes a region model to ADF faces, and then the ADF region tag will be able to place this bounded task flow onto the page. The second part of the ingredient is the bounded task flow. So you can't use regions with unbounded task flows, so it needs to expose a bounded task flow. Optional is the managed bean. If you want to have a dynamic region, then you use a managed bean to know about which are the bounded task flows to expose in this ADF region so that you can switch between them, and it knows about how to access them, so it will expose methods to switch. The fourth piece of information is the page def file, and this is the page def file of the parent page, so the page that contains the region. This page, even if it's not ADF bound, as soon as you start dragging a bounded task flow into it, will have a page def file created, a binding file created, and this will have a task flow binding reference in it, as we will see later. This task flow file reference points either to the managed bean that knows about which bounded task flow to load, or directly to the bounded task flow. And then we have page fragments. An ADF region, or a bounded task flow that is exposed in an ADF region, must be built with page fragments, and those page fragments have the extension JSFF in ADF. So how do you create a region? So if you build a bounded task flow with page fragments, then from the application navigation view you just drag and drop the definition file, or you see there's a page flows node under the web content node which would just list the page flows without the extension .xml. So either way would work. You just take the definition of a bounded task flow and drag this into the visual editor of a page or page fragment. In the context menu you see two options, region or dynamic region. If you select the region option, then this creates a static region configuration. That is, that a task flow binding is created in the page definition file of the parent page, directly pointing to the region document. If you select dynamic region, then it will create a managed bean, and this managed bean will have the bounded task flow that you dragged and dropped as a reference in it. So it will point to this bounded task flow, so that initially, if you're not dragging and dropping other bounded task flows, the behavior is exactly the same as in a static region. If you then continue dragging more bounded task flows, and if you've selected dynamic region in the beginning, then you can create command links which would then configure the managed bean with a method and with a bounded task flow document reference for you to switch between the two. So a static region, as you see here, has a task flow binding which is in the home page dev structure. You see in the executable section there's a task flow entry with the name of the bounded task flow that you dragged and drop in. And then in the property inspector there's a task flow ID that points to the document and the ID of the region. The task flow document always is addressed starting with a web inf directory up front. If there are subdirectories after that, then there's a web inf directory, subdirectory, and then the name of the document. You see a couple of properties here that you can set. So you see a parameter map. The parameter map is a way to pass in, put parameters to a bounded task flow. In the first session we created a bounded task flow that requires an input parameter. Now I could provide this parameter through a static parameter list, and you see in this property inspector a parameters section. So I can define the name of the input parameter expected by the bounded task flow, or I can have a parameter map, a hash map, that I reference through expression language, and this expression language would then make this hash map available to this property, and then all the content will be passed to the bounded task flow. Typically you would use parameter maps when you address dynamic regions, when you want to pass in, put parameters to dynamic regions where the region might have bounded task flows with different input parameter requirements. There's a refresh option, and we'll see this later when we talk about when task flows are refreshed. There's a refresh condition that takes an expression language string, and this expression language string returns true or false. If it's true, then the region will refresh, which means that the bounded task flow within will be reinstantiated, so we will start all over again. If it's returning false, then this won't happen. Activation by default is set to deferred. Now what does that mean? That means that if, for instance, you have a region within a panel tab and it's on a tab that's not visible on the page, then the bounded task flow is not instantiated, so the region is not active. As soon as a user clicks onto a tab to make the region visible, it will become active. So dynamic regions are configured exactly as static regions. The difference is in the task flow ID reference. This points to a managed bean, and you can see here that the managed bean is configured in backing bean scope, and that the method it accesses is the dynamic task flow ID. So there is a property it tries to get the current document name and ID of the bounded task flow to show in the region. There's one thing I want to make you aware of, which is a typical area where problems occur. The scope by default is set to backing bean scope. If you have two bounded task flows, and if both task flows that you switch between are ADF bound, then backing bean scope is too short of a scope. So you need to have at least view scope or page flow scope. So either change it to view scope or page flow scope. The way you do this is you go to the definition of the managed bean, which is configured in the parent task flow managed bean, or actually parent task flow managed bean definition. by default you will see the scope is set to backing bean, and you want to change that to view scope or page flow scope. If you have view links on a page that switch between, search for this view links and also replace backing bean scope with view scope. Here is an example of a managed bean. This managed bean has two entries for bounded task flows. So one entry is a shopping cart task flow, and the other one is a cash and go task flow definition. So both are bounded task flows that you want to switch between. The default task flow is the shopping cart task flow. So the first time the page launches and the dynamic region is resolved, it will get the default task flow that you have defined. But then users can call one of the methods to change the task flow ID to one of the other task flow definitions, which means that when you refresh the region, it will show a different task flow. You don't have to code that bean, so when you work with Oracle JDeveloper, you declaratively create this bean and configure this bean by just dragging and dropping more bounded task flow to a page that already has a dynamic task flow created. You can, however, edit this managed bean, put additional business logic in or security checkings in, so this bean is not overwritten. It's just extended if you add more region or more bounded task flow as a region there. Well, we already talked about input parameters, that regions can pass input parameters to a bounded task flow. Now, the one option I already mentioned is the option to use a hash map, which is good for dynamic regions. The other option, if you have a static region or if the dynamic regions always expose a bounded task flow that has exactly the same number of input parameters and input parameter names, then you can directly configure the parameters to the task flow binding. As you see on the left hand side, there's a parameter called row key, and that will be passed to the bounded task flow. This row key parameter is getting its value from the parent page's bindings file. So on the parent page we have a department ID, and this department ID has an input value, and this will be sent to the region. It's exactly the scenario that we have in the sample application. We select a department, and the department has a department ID. Now when we refresh the region to synchronize the list of employees, then this region will take the department ID of the current selected department as an input parameter, set it on a bind variable, and then re-execute the employees query. The difference is that in our sample we did not call this row key but department ID param. So let's further continue and build our sample application and integrate some regions. The Browse Departments page is the parent page, and it lives in the unbounded task flow, which means it has an entry in ADFC config. It has a navigation form that displays departments data, and in the lower part of a panel splitter component it has a panel stretch layout component that should become the container for the ADF region. Previously I created two bounded task flow, the employee detail task flow and the employee edit task flow. The employee detail task flow should be synchronized with the information coming from the departments form. And whenever we select a new record in the department form, we want to have the detail form to refresh and to show the equivalent data. So let's start dragging the information in. The question dynamic region or region, I only have one region to expose, so I go with a static region approach. And because in part 1 of this session I marked the input parameter on the employee detail task flow as required, a dialog is popping up asking for a hash map reference or for a value reference for the department ID parameter. So I can use the expression builder, and the information I need is the department ID of the current department. Because I have a form, I have a lot of attributes in my page definition file, and one of the attribute bindings I have is for department ID, and all I need to find is the input value, and this now will be passed to the bounded task flow. So what we see here is that the region shows with a greenish bluish rectangle, not really with the content. The reason why this is happening is because the default activity in the bounded task flow is not a view. If it was a view, I would see whatever the view has, a table, a form, so I would see the picture of it. Because the default activity in my use case is non-visual, I will have this greenish or bluish box here. At the same time, as I dropped the region in, if I click the bindings tab, we see the task flow definition being created. And going to the structure window, I see that the parameter is configured here and it's pointing to the department ID. This is also the way, if I want to change the information, I can do that. I just drill down to the binding and then change the values for the binding. And here is what you've seen on the slide, the different configuration settings that I have available for a region. So this is the region binding. It's not the ADF Faces region tag. I'll show you that later. So talking about the refresh option. What I want is that my bounded task flow exposed in the region is refreshed whenever the row currency on the form, on the department form, changes. And because it's running in an isolated transaction, what I needed to do is I needed to restart over again, reread the input parameter, re-execute the query, and then show the new detailed data for the selected department. To do this, I set refresh to if needed. The if needed option is good to use if you have named parameters like I have. I have a department ID parameter. If I passed in the input values as a hash map, this would not work properly, and I would have to use the default option and use the refresh condition instead, because the hash map as an object doesn't change, it's just changing its content. If, however, the value of a named input parameter changes, and if the refresh option is set to if needed, then on partial refreshing of the ADF Faces region tag, it will cause a completely reinitialization of the bounded task flow. It will reread its values, and then I would see the master detail correlation. So in my case, if needed is the right way to do it. If you use a hash map, or if you don't have parameters at all, you would use default and then use the refresh condition, which is an expression language string. One thing you cannot have, you cannot use if needed with a refresh condition. This is not going to work. So I set it to if needed. I go back to my design view, because what I need to do next is I need to tell this region that it should refresh whenever there's a data change in the form here. And the way to do this is to set up a partial trigger between the ADF Faces region tag and the navigation buttons. So let me select the region. Then here you see in the structure window there's an AF region tag with a binding that points to the binding layer, actually to the task flow binding. If I go to the property inspector, so here's the region model is referenced through the task flow binding, and then we have different options to set here. I could have a title string that I can use on an ADF region, but for me more important is the partial trigger property. So what I want to do is I want to choose edit from the context menu, then the first facet in the panel splitter contains the form, and here I do have a panel form group layout, and this has another group layout, and this has my navigation buttons. Now I select all these navigation buttons and press OK. Now what happens is that JDeveloper now configures a reference to these buttons into the partial triggers properties, which means that my ADF region now starts listening for a change, which is actually someone pressing the button. And that would then partially refresh the region, and because the region or the region binding is set up to if needed, if pressing a button means that there is a change in the record set, if there's a different department ID name, then the region will refresh, the bounded task flow will restart, and I would see the detail information. So this is the time where first time I can test my application. So far we couldn't test it because we did not have a chance to have a runnable page. So far we worked with bounded task flows. So let's take this opportunity and have a look how this currently looks. So this is the application that we built so far. On the top of the page we do have the department form that allows me to update the department but also navigate within the department. And here in this area, in the bottom area, we do have the bounded task flow exposed in an ADF region. And we already see that we can have the detail information, the detail records for department 10 displayed in the region. When I click the navigation button, then navigating in the department refreshes the bounded task flow. What happens is that by clicking the button, I send a partial submit to the server. So the server changes the row currency in the department. Because the AF region tag listens for this button, it's refreshing itself. And because the contained bounded task flow binding has the refresh property in its configuration set to if needed, it will now look into a change of the input parameter. And because the department ID now is 30, while before it had been 20 or 10, there is a change in the input parameter, so the whole bounded task flow that is exposed in the region will be restarted all over again, rereading the input information and requerying the employee data. This is how we synchronize between the parent page and the bounded task flow in the region, though the task flow runs in its own transaction. Now I can select a record here, say Shelly, press edit current row, and now I use a task flow call activity to call to another bounded task flow, to the edit bounded task flow, but I do this within the context of the ADF region. So only the ADF region now navigates to another bounded task flow. So here I can specify, say the name all uppercase, and I don't have a submit button here because I don't need that, because pressing on the train stop will do the submit for the form. And then I can do more information here and editing here, and at the end I either cancel the event or submit. And because they are sharing the data control scope, you will immediately see the data that was changed in the called bounded task flow in the parent task flow. And then I can hit commit if I want to save that value. And if I hit commit, then the only thing that gets committed is the data that is displayed in this bounded task flow here. Remember from part 1, I used a separate transaction for the bounded task flow. That means that any change in the parent page will be not impacted by me pressing commit on this bounded task flow. So the way that we can enhance our sample, and the way that we will enhance our sample, is that we want to have an undo functionality. So once I came back from this bounded task flow, I would like to have the ability to just undo the last change. Imagine that I did 3 or 4 changes in the employee structure. Now hitting roll back, and the opposite to commit, if I'm hitting or roll back, if I had a roll back button here, then the whole transaction would be rolled back. I just want to undo the last thing I did. And for this I want to have an undo button, and this is what we can use a save for later functionality for, though not really designed for this purpose, but I can do that. I can use it for that, just to give you an impression how to use it and what it can do for you. Save for later is the functionality of the ADF controller that in the current implementation in ADF works the best with ADF Business Components as the model. The idea of save for later is to allow users to interrupt their current work. For instance, if you're in the middle of filing a vacation request or doing your expense reporting and you're missing some information, then you may decide to go home because it's late and your family is waiting. but you want to continue right where you left it the next day. So for this you want to have a functionality that allows you to save the current state, not only the transaction state, but also the state of submitted but not yet committed data. And this is what Save for Later is doing for you. Just to make sure, Save for Later is not a replacement for Save as a draft, or it's not meant to be Save as a draft. So it's not something that you want to save something that is in a draft quality for a year or for a month. This is not what it's made for, and this is not what it's designed for. It's just designed for temporary interruption of work and recovering from it. Save for Later can be used in unbounded and inbounded task flows. It takes a snapshot of the current transaction if you're working with ADF Business Components, where it has access to that, and also a snapshot of memory states, but not the memory states that are belonging to the servlet spec, but only the ADF controller specific states. Now these states are page flow, view scope, and that's it. The snapshot is saved in a database. Now that means that the first time you run an application, a database table is created that will hold a block with the information about the state that is saved for a specific user for a specific application. And then this snapshot has an ID that will allow you to declaratively recover to this specific state. If there is a task flow marked as a critical, then you can use implicit save points. There's a flag, a property, and I showed that in part 1, on a bounded task flow, which is named critical. If this is set to true and Save for Later is enabled as a feature, then leaving the task flow will implicitly take a snapshot, so that if things go wrong after that, you can recover to the state that you had when you left that bounded task flow. Snapshots by default last for 24 hours in the database. They're not deleted necessarily after that, but they're invalidated. What gets snapshot is the user interface state. So if I have a submitted form, but that is not yet committed, then the data is available in the ADF binding in the model, but it's not available yet in the database. So this information will be snapshot and saved in this blob as well. Then we have manage bean configurations. If the manage bean is in one of the ADF task flow memory scopes, then this also be saved up. Just make sure it's configured to be serializable, because that is what is required for it to be saved. Navigation state is also saved. So if you have a bounded task flow that is opened by another bounded task flow, by another bounded task flow, eventually opened up in a dialog, then this state also is snapshot. Before we can use the save point feature in our application, we need to enable this in our project. We enable this functionality in the ADF config file, which you access through the application resource accordion panel. This contains a descriptor folder, and this has an ADF meta-inf directory. One of the files in that directory is the ADF config file that you double-click to open the editor. In the controller section, there is a setting for save points. And what it wants me to do is to configure a database connection that it uses at runtime to create the table it needs, just in case the table doesn't exist, or to save the snapshots that I'm taking within my application for this specific user. So in my case, I go with the HR connection, which is fine. Implicit save points, well, I mentioned this is a functionality of the bounded task flow. If you mark a task flow as critical, as soon as you leave that task flow, it will take a snapshot so that you can always come back to the state of this task flow when you left it. So I don't need that in my example, so I'm saving the configuration as I have it here. Next step is to set a save point, and I want to have the save point to be created when the user navigates from the employee overview page to the employee edit bounded task flow. So changes that will be applied to a row within the employee edit bounded task flow should be undone in the employee overview page. And this gives me a nice way in my example to undo a single row change right after the row has been changed, of course. To do this, I use a method call activity. The SavePoint functionality is exposed on the controller context API, and I can use Java or expression language to use that functionality. So I drag and drop a method call activity onto the diagram. And then what I need it to do is I need my bounded task flow to navigate to it. So I'm trying to get the endpoint here and just change the navigation flow to the method call activity. So give this a meaningful name. Always keep in mind that a diagram is also a way of communication to others. So let's put the save point in here. And the next is that I need to create a navigation case or navigation control, as we call it in task flow, then eventually to the employee edit bounded task flow. What I want to do is I want to give this a meaningful name as well, though I could keep the wildcard navigation flow, but I want to have a meaningful name so it's better to read. So let's call it SavePoint set. And to make sure that the method call activity really returns this outcome so that navigation continues, I need to set the same value for the fixed outcome here. So let's call it SavePoint set as well. This error icon that I see right now indicates that the method property of the method call activity is not set. And this is what I need to do next. So for the method property, I open the expression builder. And then under controller objects, there's a controller context object. And in here, there is a SavePoint manager. So I can go to the SavePoint manager node. And this has an entry create SavePoint. Again, it's the same entry I could call from Java, but why do I want to use Java if I can use expression language? Now this invokes this method on the controller context, and in return I get a string with the ID of the SavePoint that is identifying the snapshot in the database. To get this SavePoint ID, I use the return value of a method call activity. Keep in mind that method call activities can be used to call any kind of Java method in a managed bean or even on the binding layer. And methods might return a value that you then continue working with, and that's exactly the case here. I could store the return value in memory, so I could just take a memory attribute and store it there, or I can save it up in a managed bean. I already mentioned this when we talked in the first part about how to save input parameters for bounded task flows when they're called, that for production applications, for real applications, not demo applications, it makes a lot of sense to use a managed bean to save the temporary values in there. One of the reasons is documentation. The other reason is that you can use expression language to discover those properties, because everything you save in memory is not discoverable at design time. So we already have a bean created in PageFlow scope, and this is the bean that we used to hold the input parameter that is passed to the employee overview bean or overview bounded task flow, and this bean is in PageFlow scope. So let's add a string to hold the SavePoint ID and say to null some documentation, SavePoint is taken when navigating from employee overview page to edit bounded task flow. So then we generate accessors, save it, and now we have a nice declarative way of storing the return value, which is in here, of the controller save point functionality. So again, use expression builder. Then we go to the bean, which is here, and now we see a save point entry. And that's it. So what we achieved right now is that within the process of navigating to the employee edit bounded task flow, we use a method call activity to set the save point and to save it up in a managed bean, which is in page flow scope, so that I can use it throughout the lifetime of my bounded task flow. If you need a larger scope, then you can have a managed bean even in session stored. So if you want to exit this bounded task flow and still being able to recover to the point, then you could just use a bean in a larger scope. Last thing I need to do for this feature is, at least in the bounded task flow here, I need to find a way to restore to the save point. First of all, what I want to do is I want to copy and paste this, though I could easily get back to this string by just using the expression language builder, but just to shortcut for this video demonstration, I copy the string into the clipboard, and now I need to restore, and the restore is through navigation, and there's a method activity or an activity which is called the save point restore activity. And this save point restore activity only takes as an input property the save point ID to which it should restore the bounded task flow. So I paste my previously copied string in, and then I create a navigation case from here to there. So this means that if I follow the control flow case from a command item that returns undo as a string, it ends up here, it looks up for the save point, and when it finds the save point, it will restore to that. One thing I didn't implement in this sample is I didn't check for null value. So you can use easily expression language to check if a specific value is null. In this case, you don't want to restore, you want to navigate somewhere else. So one way to handle this would be to have a router between the employee view and the save point restore. So this router will check if the save point ID in the managed bean is null. If it's null, it would navigate back to the page and would not do undo anything. If it is null, it will continue navigation to the save point restore. You see how you can declaratively draw even complex decision-making processes in a bounded task flow. So next step is to create an undo button. So what we do, we just go to the component palette, take a button and drop it here, and then we call this button undo last change. And the action of this button, all that we need to do setting it to undo. Save and see what we get in running the application. This is the application view at runtime for department 30. You see the list of employees and already one employee that I selected. Note that the commit button and the undo last change button are disabled. I didn't show that in the example when building the undo functionality, but what I did is I used expression language in the disabled property of the button and point it to the page flow scope employee detail process bean and there to the save point ID property. And I simply check if this property has a value of null. If it has a value of null, then obviously there's no save point for me to set, and this is one way to protect the save point from failing. The other one is what I explained while talking you through the building steps, is to use the router activity and then check if the save point ID exists. So you can protect this both ways on the UI and in the navigation flow. So when I press edit current row and make this all uppercase here, I can go straight to HR because I have no need to edit the person, and since this is a non-sequential train, I can just skip one train, stop, and press submit immediately. Next, what you will see is that the commit button is enabled because I changed the transaction, but the undo last change button is enabled as well because now the manage bean property has a value which is a save point value that I set through the method call activity I showed when we built the example. And now when I click the undo change button, when it comes back, you see Shelly is in uppercase first letter and the rest is lowercase. Commit and undo last change are disabled because what it really does is it brings me back a step in time. The question that is valid for you to ask is, well, Frank, you had the cancel icon here on this form. What is with that? Well, it would do exactly the same thing here. It would just undo the last thing you did in a transaction because it sets a save point if the bounded task flow is shared in its transaction. So if the bounded task flow you call shares the transaction with a calling task flow, then you can implicitly set a transactional save point if you're working with ADF Business Components, and the cancel just will use a return activity that has restore to save point set in its properties. However, once you press submit, you're back in the calling task flow and this cancel option is no longer available. And here is why undo last change makes sense. Again, here, though I didn't really change something, I took a snapshot, and this is why this undo last change button is enabled. So I can always go back to a specific point in time. In this case, the way that I implemented this, it's the last state of this table before I started editing the selected row. The next topic to cover in this session about task flows in Oracle ADF is to talk about launching a task flow as a dialog, which you can do for bounded task flows, and you can do so declaratively. This screenshot shows a bounded task flow that is launched in a inline pop-up, and it's launched from a LOV button that is arranged next to the department ID on the calling page. The bounded task flow that is launched in a dialog can of course have the same multi-steps and the same large processing as it has when you just navigate to it. So there's no difference between launching the bounded task flow in a dialog and just executing it on the same level of the page or within the page. Here's a diagram of two task flows. The top bounded task flow is the one calling the dialog, and the lower one is the content of the dialog, as you've seen that on the previous page. The browser employees page has a command button, and this command button navigates to the task flow call activity, and this task flow call activity, as you see in the property inspector, has in its behavior category the run as dialog setting set to true and the display type set to inline pop-up. The bounded task flow that is called has a return value defined, and the return value that it defines is for the department ID parameter. So the return value parameter name is department ID, and this gets returned by the bounded task flow, and because it gets returned by the bounded task flow, it has to be specified on the task flow call activity. When you launch this dialog, you do this from a command item. That could be a list of value button, menu item, or a link. Important is that you set the use window property on this command item to true, and that you specify a height and a width for the dialog. So this is where you specify the size of the dialog that the dialog should have. The navigation action under bullet point 2 is set to launch, which is the normal control flow case that you create between the calling page and the called task flow call activity. And in bullet point 3, here is the return listener definition that allows you to point to a manage bean method that now waits for a dialog to close and to return the selected value. And with this value, then you can refresh the form or just update the department ID field and then refresh the form or whatever needs to be done. The functionality behind this is the external dialog framework, and it allows developers to declaratively launch pages as documents as a dialog or a bounded task flow. This functionality only works if you use the ADF controller, so it doesn't work with the native Java Surface navigation model. You can launch the bounded task flow in an inline pop-up, as we've seen in the screenshot, or external window, which I just explained. A launch listener can be defined on the command item to pass information into the starting dialog, and the return listener to work with the returned values. The external dialog framework requires that the documents are JSPX documents and not page fragments. So this is for the open dialog. Of course, the dialog itself can be called from a JSPX document or a page fragment, but the content of the dialog must work with JSPX documents. To implement the dialog functionality in our sample application, I like to launch the employee edit bounded task flow in an inline pop-up. So far we navigate to it from the employee overview bounded task flow to the edit task flow. Now I want to have the edit task flow to be launched in the dialog. For this I select the task flow call activity and then I scroll down to the run as dialog section. Here I set run as dialog to true. Display type is inline pop-up, and I don't have a return value to specify because the edit bounded task flow and the employee overview bounded task flow share the data control. So that means that a change in the transaction is automatically synchronized through the data control, and all I need to do is really to refresh the table so I can see the changed data in the calling task flow. So all I need to know is when the dialog is closed, and this is what I can do on the launching command. So here I have the edit current row command item. So I scroll down and here set the use window functionality to true and specify the width and the height for the dialog to open. And then I have a launch listener setting and the return listener setting, and I want to use the return listener to notify the calling page or the calling command when the dialog is closed. And then in response I want to refresh the table. To make it easy for myself, I will create a JSF component binding of the table to the same bean that manages the return listener. And because a JSF component binding has to live in a request scope, I need to use the request scope for the bean instead of the existing bean that I have, which is in page flow scope. So I press edit here and create a new bean. And because this bean is like an managed bean, I call it employees overview bean. Maybe with a lowercase start, and then create the class and the package. Let's put it in bean. Request scope should be created if not existing, and that's fine. And then I create a method in this bean, and this I call onDialogReturn. onDialogReturn. And okay, the dialogs, and this will create the employee overview bean with an entry for the dialog return. The return event gives information about the dialog return values, if there are any. I mentioned that you can have more than one value returned from a dialog or just a single value, and this gives you access to this functionality. Now what I want to do is I want to first create a JSF component binding, and I want to create this component binding from the table. So selecting the table. So I'm searching for binding, and this JSF component binding will give me a handle to the runtime instance to the rich table instance that is created for the table, and then I can grab it and refresh the table if needed. So let's call it employee table. Employee table. Okay. Back here I now have my entries for the table, so I have employee table, and then all I need to do is on the return event I call ADF faces context ADF faces context get current instance, and here I add the table to the list of partial targets that should be refreshed with the next response. So let's do this, add partial target, and here just put the employee table. That's it. So the last thing for me to do is to correct the little error that I'm getting here on the bounded task flow, indicating that the task flow I'm about to call is not built with pages, it's built with page fragments. So I need to change that. So I have 3 views here, and each of the view is a page fragment. So right mouse click into here, and then convert to task flow with pages. I can keep the page fragments if I want, so in this case I could reuse this page fragments in other bounded task flows. In my case I don't need that, so I press OK, and the framework now will convert the page fragments into page documents, which technically is just like adding an fview tag to the page fragments. Close it all up, and now run it again and see how the completed application looks. The sample application is now function complete, and the last thing for us to test is the bounded task flow in a dialog. So again we select an employee, and then we press edit current row. And this time, as you see, the edit bounded task flow opens up in an inline pop-up. So I can step through the train, and here when I click submit, this will lead to a refresh of the table, and then I can see the changed value here. And again I can press undo last change to undo the last change. So functionality wise there's no difference between executing a bounded task flow in a normal task flow call activity or region or as a dialog. The last topic in this ADF Task Flow overview recording for ADF Insider is to talk about remote task flow deployments and remote task flow access, which gives you the ability to use a task flows almost similar to how you would use web services, just with the difference that this remote task flow will have a user interface. First of all, bounded task flows are deployed to a remote server as a Java EE application. So you just deploy the project that contains the bounded task flow as a Java EE application. They're not sharing the session with a caller. So a bounded task flow calling another remote bounded task flow will not be in the same session. However, due to bounded task flow having input parameters and return values, you have a clearly defined APIs that the caller can use to send data into this bounded task flow and return an output that then the calling task flow can work with. A remote task flow must be built with JSPX document, so it cannot be built with JSP fragments or JSF fragments in Oracle ADF. The URL invoke property of the bounded task flow must be set to URL invoke allowed. because even if you call this from a task flow call activity, it's a remote call, so it's issuing a GET request to the remote server. Here's an example of how the task flow call activity definition looks like. So what we see here is there's a task flow call activity, and this has a task flow reference, and this task flow reference contains the webinf / and then the name of the bounded task flow document to call, and it contains the document ID that we're referencing. Further down you see an element, an XML element called remote app URL. Now this is the reference to the remote application server that hosts the bounded task flow deployment. In our example, because we don't want to hard-code server names in our application, which makes it less flexible, so in this recording and also in our product documentation, we use a context parameter in WebXML that allows you to change the URL after deployment easily without having to redeploy the application. So instead we use an expression language string init param, because it's a context parameter in WebXML, and then there is a key name. In this case it's ADF sample remote taskflow.url, and you can make the name any way you want the name, any way that your naming convention in your company is. And the WebXML snippet that you see at the bottom end of the slide, we have a context parameter defined exactly with the name specified in the expression language string. And here, as a value, we just provide the absolute server address up to a very important path entry. It's a servlet entry, which is ADF point task flow or task dash flow. So you must have this ADF point task dash flow in it, because this is a servlet that identifies this request to be a bounded task flow request, and then the ADF controller will take care of the request and not Java server faces. This information actually concludes the overview of ADF task flows. Of course, there's more to learn. If you visit oracle.com/technology/JDEV, you find downloads of the software, tutorials, samples. You also find an entry to the discussion forums and the ADF developer guides. The ADF Insider homepage is a website you want to bookmark, because it contains a lot of videos like this that step you through features and processes and development tasks in Oracle ADF. It also has a video on it that is called the ADF region interaction or ADF region communication. It's a logical third part of this series that we're concluding here, and this focuses on how to communicate between different regions on a page in different scenarios, in different situations.